Welcome to class number I don't know. We will start today question number. Now onwards I will be more tell about question numbers. Okay. 51, 52 today. Now make a note. Master questions are over rectangle, triangle, whether it is right angle triangle or isosceles triangle or triangle in general, circle, semicircle, quadrant, everything is very thoroughly, systematically explained in the beginning. Lot explanation, examples are over, master questions are over, very thoroughly explained. So now onwards, I will not waste time. Briefly I will tell, even then see, that is called teaching instinct. I can as well give the question and answer, but no. Let the question continue. See, earlier all, we had done so many parts. That is only for understanding. Now, simple question. See, 51, 52. Two questions reason. See here. A triangle here. Here also triangle. Rectangle will come here. Rectangle will come here. Semicircle will come. Semicircle will come. Both are same. The difference is that, see, 150 here. Here also 150. 120 here. Here also 120. See here. This radius given 105. So diameter becomes what? 210. Here also see 120 plus 90 is once again 210. Everything is same. The only change is that here this is 90, this is 120. Little smaller, little bigger. But here no data given. So understood that it is a midpoint. If this is 210 total, 105, 105. So therefore that is the only change. So okay, start. First question 51. What is required? Ix, x, iy, etc. Therefore x bar, y bar question. For this question, see, there is no symmetry. This way symmetry is not there. This way symmetry is spoiled because of 90, 120. So this question, see, but next question, this way symmetry is there. So therefore x bar, y bar both are required. Okay, start. Consider. Now, one more thing, see here, right here, the upper one is a triangle in general. For a triangle in general, when you want moment of inertia about, see, this type of triangle, this axis, there is no problem. You can take a single triangle, but you cannot take single triangle when you want I about vertical centroidal axis. You can take it, you know, one class I told how much lengthy it becomes. So it is advisable when the triangle is, if it is a right angle triangle, well and good, right? Take as it is. I told already, right angle triangle, take as it is. Isosceles triangle also take as it is. But if it is a triangle in general, then you divide into two parts. So what you do is, see, you divide here now. See, I will show here only. You write this question once again and write here. See, this way we will divide. Write once again the question. Okay, and then this way. See, triangle, right angle triangle, right angle triangle, rectangle and semicircle. Okay, start. 90 by 120. See here. 90 by 120. This base is 120 by 120. Both are equal. Okay, that hardly matters. This is 120. This is also 120. Just to understand later, I will put one of the 120 as 120.0. Not right now. Little later, I will put one of the, when I do moment of inertia, I will take, because they need not be equal. Okay, then rectangle, full base required. See, 90 plus 120 is 210. Okay, full over. Height given 150. And this semicircle, see, they told this is 210 means it is nothing but diameter only. So for the semicircle, what will happen? Your diameter, where to write here? Okay, I can write here. Your dia is equal to 210. I think it is visible. Okay, dia equal to 210. Make a note. Correct, 210. Yes. If the diameter is 210, this is radius 105. 120 plus 150 plus 105. Total vertical outer to outer 375. Horizontally 210. Okay, start. X bar, Y bar. Part 1, Part 2, Part 3. part 1, part 2, part 3, part 4, your choice. As usual, we will take origin here. Remember, Abelco, you write, Abelco is the Abelco here, x, y. Start. Area, I don't have to explain area. Area I will not explain. Half base into height, half base into height, base into height, and here pi by 8 of diameter square. Numbering is correct. No, there is some problem here. Oh, what happened? Yeah, sorry. This is 1. Okay, correct. So 1 is pi by 8 of diameter square. 2 is base into height. 3 and 4 are half base height. That is not a problem. Okay, start. X distances. First of all, this also not required. Okay. From C. I told you 1 by 3, 2 by 3 of 90. 1 by 3, 2 by 3 of 120. 1 by 3, 2 by 3 of this 120. 1 by 3, 2 by 3 of this 120. So I will do one thing now. The base I will put 120.0. Just to understand, I will put 120.0. Not now. When centroid or moment of inertia comes, I will write this as 120, that as 120.0 to show that they need not be equal. Okay. Then this distance, center here. This is, see, this way is center, midpoint. See, 210 means this is half of 210, half of 210, but this way is 2d by 3 pi. Okay, start. y1, x1, this way, 210 by 2. x2, once again 210 by 2. x3, 2 by 3 of 90. x4, 90 plus 1 by 3 of 120. 90 plus, where is it? 90 plus 1 by 3 of 120. 120 which one? 1 by 3, that's now important. 90 plus, I will write once again now, see, to understand. It is 90 plus 1, this ink is a problem, okay. It is, okay, 90 plus 1 by 3 of 120.0. Because 120, one third of this 120 point, one third of 120 is how much? 120, 40, 45, 130 I think. Just 1 minute, I made a small note of the x and y there. 130, correct. Okay, then y distances, see here. y1, this distance is 105 minus 2d by 3 pi. y2, 105 plus 150 by 2. y3 and y4 both are 105 plus 150 plus 1 by 3 of this 120. So it is not 120.0, 1 by 3 of 120, not 0, one third of 120. Okay. You will get total area is here, you get x bar and y bar. Using this data, we got x bar, y bar. I will remove this one now. We will go to moment of inertia calculation. To save the time, I will first mark the axis, then I will get, see, x bar 103.974. From here to right side 103, see here, this is 90. So after 90, these two centroids are at 210 by 2 is this, 210 by 2. 210 by 2 is how much? 105. 105, but you got 103. So slightly before. So your axis will come, that 4 is disturbing me. I will shift that 4. 4, go that side. Don't disturb me. 4, okay. See, it is after 90, but before. But how much before? Slightly before. Little before, see. See, this is center of circle. See, center of circle is here. This is center of the circle and centroid is at same level. Okay, now this is your, okay, extend here. Y axis, see here. See, same, I should be here. I should be careful now. Yes. See, these small things, even the semicircle is not fully correct. It's little tilted. Don't give importance to that one. Why y-axis? Now write here distance. Where to write? Distance from here is, I write here now. The diameter is disturbing me. I'll put diameter once again. See, this is how much? 103.974. 103.974. Then from that extreme end, from this extreme end to here will be, I already calculated somewhere there. I already noted down the answer because to save the time. From total 210, subtract it. 106 point, I'll check the camera once again. 106.026, correct? 639, correct? Okay. Now, y bar, we got 169.879. See, 105 up to here. Up to center is 105 plus another 75. 105 plus 75 is 180. We got 169. So, slightly below. See, why? Because here is 105 plus 75. 180. But you got 169. Okay, therefore, little earlier. These are high school level mathematics, XX. And from the bottommost level here, this distance is how much? Y bar 169. Okay, there is no space here. Okay, I put here 169.879. Whenever space problem is there, I will write in between. Okay, and therefore, from the topmost edge up to here is subtract total 375. This is 205.121. Okay, round off. Okay. This is your centroid G for the entire lamina. Now you have to calculate moment of inertia. Before I go to moment of inertia calculation, I will tell, I will tell, as I write, I will explain. Okay. Okay, now start moment of inertia. Don't see this side. Before starting, as usual, I will tell you triangle here, semicircle, its own centroidal axis will be here. Now I will not waste time telling again and again Ig plus A square. If it is not clear, you do not continue any class from me. That's all. See, I about its own axis. It is not symmetrical. So, decimal number will come. For semicircle, decimal is 0.00686. But when you do I about YY axis, see, this vertical centroidal axis, it is symmetrical. Therefore, pi by 128 of diameter power 4. Rectangle I will not explain. Triangle also I will not explain. Okay, start. Start first one. I about, see here, its own centroidal axis here. 0.00686 into 210 power 4 plus area into, from, see, area into with distance square. From centroid G1 to XX, this distance square is, see, this distance square is 169.879. Subtract 105, you will get this distance plus 2d by 3 pi. Yes, whole square. For 2, I about its own axis. 210 into 150 cube by 12 plus area into, see, from G2 to here, this distance square is 205.121 minus 120 minus half of 150. Half of 150, where is it? 150 by 2 whole square. Okay. 3, I about its own centroidal axis. 90 into this 120. 120 cube by 36 plus half into 90 into 120 area into this distance square. This distance square is 205.121 minus 2 by 3 of that 120. 120, okay. Fourth one, same as third one. See, I about its own axis. Only change is 120.0 into 120, just to differentiate. 120.0 into 120 cube by 36 plus area into same as G3, this distance square, you get IXX. Okay. Now what to do? Nothing to do. This I told last time. If somebody will ask, sir, what is next step? So, okay, you wrote everything. No, don't continue my class. After all this telling, find to IXX total and write the answer. Okay. I about YY. First here, about its own centroidal axis. This is symmetrical axis. So, pi by 128 into 210 power 4 plus area into, see, centroid is here into this distance square is 106.026 minus this distance is exactly half of 210 whole square. Rectangle, I about its own centroidal axis. 150 into how much? 210 cube by 12 plus area into this distance square. That distance square is same as this distance square. You can make out there because why? This is also 210 by 2. This also 210 by 2. Here, I about its own centroidal axis. See here, this one. Its own centroidal axis here. Parallel side, 120 into 90 cube by 36 plus half into 120 90 area into this distance square, that is 103.974 minus 2 by 3 of 90 whole square. Lastly, I about this axis first. 120 into 120.0, just to differentiate them, cube by 36 plus area into this distance square is 106.026 minus 2/3 of 120.0 whole square, get IYY. Okay, now question number 51 over. I can remove 51 now. I will start 52 briefly. See, 52 I will start now. I will remove 51. Something you are right in 52. See. In question number 52, first you are write a note. See, copy the question. Then make a note here. Note. See, this is 105. When the radius is 105, surely, I will remove all this one. Okay. When the radius is 105, this is how much? This is 210. Okay, this is 210. Then therefore, divide into parts. See, this way. A semicircle of diameter 210, same as last time. A rectangle of 210 by 150. Here, see, this is 210. This distance and this distance are not given. These are not given. You write the sketch. Then write, since not given, it is understood that both equal to, this is 210 by 2 equal to 105 millimeter. Right. Therefore, if I take this as part number 1, this as part number 2, last time, see, it is still there. We took two different triangles, but this time, now right here, now the triangle becomes isosceles triangle. Therefore, dividing into part is not required. You can take a single triangle, write 3. This all I told earlier. Not once, many times I told. Okay. This much, make a note. Now, I will change the sketch slightly. And one more thing, now only. One more thing you have tried. Now, see, you can see here, this is axis of symmetry. This is axis of symmetry, that will become your YY. So, your X bar is not required. See, these two will be, if it is 210, both are 210 by 2 and 210 by 2. Therefore, you have to locate, see, we have to locate only XX axis. Therefore, only Y bar required. Only Y bar required. Yes, that much note you write and start the question. Start now. See, I already told you y see here. Now this is semicircle of diameter 210. This already told for you. This is rectangle, figure number 2. Last time there were two triangles. Now single triangle. See, base 210, height 120. See, I hatched it this way, both together. This is 2d by 3 pi. This is center. This is 1 by 3 of 120. This is 2 by 3 of 120. Okay, start. To locate x-axis axis, y bar required. Consider AB as reference axis. See, AB for y calculation, y upward. Part number 1, area. I already told you just now. Part number 2, already explained. Part number 3 is half into 210 into 120. Half into 210 into 120, area will come, total area, y1, already explained. This distance, 105 minus 2d by 3 pi. y2, don't see x-axis, still pending. y2, 105 plus half of 150. y3, 105 plus 150 plus 1 by 3 of 120. So with that calculation, find y bar from AB. You write the formula A1 y1, A2 y2, A3 y3 by total area. You calculate. I also will calculate, but I can do super speed calculation. 169.879. 169.879. Students will tell, sir, that is same as last time answer. No, there is no last time. You calculate 169.879. So why it came same? It came that much. You solve the question. That all you worry later. Okay, over. Now, go there, go to the main sketch and locate x-axis. See, 169.87 is 105 plus 150 by 2 is how much? 180. So little before, right, over. Now, calculation of I, moment of inertia. Write all the statement. I about any axis equal to what? Usual statement. IG plus A square, all you write yourself only. See, I have not rubbed the previous two. Tell why it will come same. Okay, see now. Once again, figure number 3 I will explain. Start. Figure number 1, centroid is here. I about its own axis. Just now told. How much? Pi by, no pi because not symmetrical. 0.00686 diameter power 4 plus area into this distance square is 168.879 minus 105 will give this distance plus 2d by 3 pi whole square. For 2, I about its own centroidal axis. 210, this is 105. 210 into 150 cube by 12 plus area into this distance square is 205.121 minus 120 minus half of 150. All same as last time. Okay, now, I about x for 3. Plenty of space is there. X for 3 equal to, see correctly now, I about first its own axis. See here, this axis. Remember, for this axis, there is a base and height. See, for this axis, there is a parallel base and height, and the base is extreme end. When the base is extreme for a triangle, moment of inertia is same as right angle triangle, BH cube by 36. So base is 210. This all I see. This all told many times earlier. 210 into 120 cube divided by 36 is the area IG plus half into 210 into 120 is the area into, okay, from centroid to XX, this distance square. This distance square is 205.121 minus from here to here is 2 by 3 of how much? 120. 120 whole square. Ink is little faint actually. Zoom and see. Okay, over. Now get the moment of inertia. Next, I about YY. Start. Here, see. First, I about its, now the centroidal axis coincides with YY. See, your G1 lies in YY. See, G1 is not lying in XX. So when you want I about XX, from G1 to XX, this distance square, G2 to XX, this distance square, G3 to XX, this distance square. But when you want I about YY, see here, G1, G2, G3, all of them lie in the YY axis. So I, after writing IG, area into, when you do moment of inertia about vertical axis, horizontal, there is no distance. See, from here to this axis, no horizontal, 0 square. So remember, so start. I about its own axis. Pi by 128, 210 power 4 into what? 0 square here. I about its own axis. 150 into 210 cube by 12 plus area into 0 square IYY for 3. Okay, color is not there. I'll put, okay, 3 is there. Equal. Now be careful. Moment of inertia about, see, axis passing to centroid parallel to YY is this axis only. But remember, for this axis, parallelly, there is no base, or this axis passes to center, or this actually divides this total triangle into two parts. It's a common base. Common base, if it is not at the edge, if it is in between, then the moment of inertia, I told repeatedly, if you want I about this axis, the parallel side 120 into the perpendicular full side, how much? 210 into 210 cube by 48. I told, this is, I think most probably already told more than 48 times. I'm so sure. Already explained very thoroughly, words, example, basic part. See, if you don't go through basic part, you won't learn from my class. Plus area, half into 120 into 210 is the area into 0 square. Why? Centroid lies in YY. If anybody gets confusion, sir, why you used 48? You either at least be serious now and go through all the earlier explanations. See, titles are given, important explanation, very important, triangle, etc. Either you do that one or leave my channel. Do not depend on me. You study by somewhere else where people will teach you much better way than me. Okay, if you find, go there or study from there. So there is, that I already told, there's a limit for everything. If anybody will raise a doubt, see, in the offline class, if someone will doubt, I will look at them. What you are doing all these days? How many times I told? Little angry, but I am not angry actually. Online class, I can't show anger because why? You are not in front of me. When you are seeing this class, I am not taking the class. But you can imagine the way I talk. Then that will tell you, oh, this, see, in my class, if I write anything without explaining, it is 100% sure it is thoroughly explained many times. Otherwise, I will not just skip and tell, okay, do this way, okay. That way I never talk. Okay, now, this question over. Next class, 53, I will continue next class. Enough for today. Again, lot of commitments. So, heavy class I took today, therefore, enough. Thank you. We will meet in the next class.